All right, so let me put this in. All right, so last time we talked about high-level languages and low-level languages. And today we want to look at sort of how a high-level language can get translated into a low-level language. And hopefully this makes sense to you that this would have to happen. So imagine, if you wanted to talk to somebody that spoke one language that you didn't speak. Okay, so suppose I speak English and another person speaks Russian, and I don't speak Russian and they don't speak English. What we need is a interpreter or a translator, something that will go in between us and translate or interpret from my language that I speak into the other person's language that they speak so that we can communicate with one another. Okay, well, that's really exactly what happens with computers as well. So we need either some kind of translator or interpreter as a go-between from a high-level language, the language that the programmer is speaking, to the low-level language, the language that the computer processor is speaking. Okay. Now there's a difference sort of between interpreter and translator. I've been using both those words, but if you think about it, an interpreter, typically this happens on the fly. So for example, like when I go to church, there is somebody there that is able to speak sign language so that hearing impaired people can participate in the church service. And so that person is an interpreter. So they listen to what a person is saying, maybe what the pastor is saying during his sermon, and they listen to a sentence, and then they turn that into sign language, and then they are listening to a sentence and do the next. And so as the sermon, sentence by sentence, is coming in, the interpreter is taking that sentence and translating it and taking it and translating it into sign language. Okay, so there's this real-time idea behind the word interpreter. Now, if you've ever taken a foreign language class, you've also probably done translation. And usually this isn't an on-the-fly kind of thing. Usually a translation, or maybe you've read a translation. So, maybe you've read the Odyssey, and that originally was written in Latin. And so we would take, somebody took that book written in Latin and interpreted the whole thing into English. Okay, so changed all of the Latin into English, and then they took that translated thing and gave it to you. And now you have a translated version that's in English. Okay, so that translation process where it's not on the fly, it's not somebody reading the book in Latin and reading a sentence and then telling you what it is in English and then reading a sentence. They did the whole thing at once. And that's kind of the difference between interpreters and compilers. So the interpreter is a program, okay? It's another computer program, but it's running on the computer, and its job is to read and execute a line at a time of a high-level language, like the person at church that's doing the sign language, or like a person who would read the Latin book and then one sentence at a time and then tell you what it is in English, and then read Latin to English, Latin to English, Latin to English, like that. Okay, so that is what an interpreter does. It's kind of this on-the-fly thing. Okay, a compiler is more like someone who sits down and translates the entire book and then gives you the entire book to read. So a compiler reads and translates the program completely before execution, before somebody starts looking at the English part of it. Okay, so hopefully that kind of gives you an idea of the difference between an interpreter and compiler. It's kind of the difference between interpreting on the fly and translating, where you do it all ahead of time before you produce the entire translation to the other side that's needing the other language. Okay, So that's interpreters and compilers. So traditionally, this is figures from your book, and this is a very traditional view of what an interpreter does versus what a compiler does. Okay, so notice they both begin with source code. So you have source code written in a high-level language like Python or C++ or Java. Okay, so if we have an interpreted language, the interpreter is a program that's running, and its job is to look at the source code and then figure out what the source code means. Okay, do whatever the source code means, and then give output. Okay, produce the output that is desired, that is directed by the source code. Okay, that's its job. Okay, and so how it does that might be different interpreters do those things different ways. Okay, but one thing that we notice, this is a program that's running, and its job is to read the source code and produce the output. Okay, and now it might do that by translating into machine code, but it might not. It might just say, oh, I know it wants to do this, and it looks up how to do that, and it does it, and then gives the output. So it's not, it might not, and probably is not converting it into machine code. Okay, it's doing all the interpreting and the translating itself. Okay, so that is how the interpreter process goes. Okay, on the other hand, a compiler, okay, takes that same source code and runs it through a compiler. This is a translator that translates from the high-level language that you wrote into something called object code. Object code is basically binary code that can run on the computer. Okay, so it converts from the high-level language to a bunch of ones and zeros. That's specific for whatever processor that you're compiling for. Okay, and then once that object code is created, you can feed that bunch of ones and zeros into something called an executor, and it feeds it to the hardware, make sure that the hardware runs it, the processor runs it, and the executor produces the output. Okay. So one thing to notice here is that compiler's job is to translate from a high-level language into the machine code for that particular processor. In an interpreter, we probably never actually can take the source code and turn it into machine code. It just runs it itself. Okay. And so, of course, when we talk about these are the two different processes, interpreters are compilers. So the question is, well, what is Python? Because that's what we're using. That's probably what we're interested in. Is Python interpreted or is Python compiled? And this is a tricky question. Okay, so Python is considered to be an interpreted language. Okay. But the way that Python is interpreted actually involves a compilation step, and so you might sometimes get confused. Well, why isn't it compiled then? Okay, so let's talk a little bit about how Python works. So you will use some kind of an editor to create a source file, and then that source file is fed to the interpreter. And from the outside, if I don't know what the interpreter does and I have no idea, I just know that it's the interpreter's job, the Python's interpreter's job, to read lines, to read my code from my Python program and to make it run, to produce output. Okay, so that's what it's doing. And because that's all hidden from me, it is an interpreted language. Python is an interpreter. Okay, but if you went and looked at the implementation of how the Python interpreter works, there is a compilation stage where it takes your computer program and it runs it through a compiler and it turns your high-level language into something called bytecode. Now this is different than machine code. So this bytecode is independent from your processor. It's just something that the Python interpreter or the Python virtual machine here understands. So it just gets interpreted into this bytecode that's also high level. It's not machine code, okay, but it's something that's understood by a Python virtual machine. And so that Python virtual machine will read in that bytecode and use libraries and other things and to be able to run your program and produce output. So again, it's never getting converted into machine code. It's just running on this virtual machine that's just a program. But there is a compilation stage. And so it's sort of, in a sense, it's both compiled and interpreted if you know how the interpreter works. But at a very high level, abstract level, we would just say it's an interpreted language. But compilers tend to produce more efficient code, and so the Python interpreter chooses to use this compile stage so that the code can run faster. Remember, last time we looked at one of the disadvantages of high-level languages is that the programs don't run as fast. And so by using this compiler stage, it can do some optimizations and things like that make the code faster. And so it kind of gets the best of both worlds. It can be a little bit it can be faster, but still be a very high-level language and be interpreted. Okay, so as we said, Python is considered an interpreted language because the Python program is executed by an interpreter. It's not executed by like the processor itself. It's executed by an interpreter. Okay, and there are two ways to use the interpreter: in interactive mode and in script mode. So I'm going to give you a little demo here. Okay, so here I've got my a command console popped up, and I'm in a directory. I've written a little Python program that we can look at. But before we look at the Python program, I'm going to show you what script mode is, or sorry, what interactive mode is. So interactive mode is a command line shell gives immediate feedback for every statement that you enter. Okay, so here, if I just type Python, okay, and then I hit enter, it's starting up the Python interpreter. Okay, and so I can feed it instructions one at a time, and I'll tell it to do something, and it'll do it. So I can say like 2 + 3, and it will give me feedback. It'll produce output for that. Oh, that's 5. I could do A equals 2 + 3. Okay, and it doesn't, all it's doing is here, it's taking 2 + 3, evaluating that, and it's storing it in a variable called A. And so if I just did A, it'll tell me, oh, the value that I have for A right now is 5. Okay, and maybe I could do B equals 3. And then if I do A plus B, well, it had a value of 5 stored for A. It has a value of 3 stored for B. So it can look up the 5 and the 3, add them together, and it'll tell me, oh, that would give you 8. Okay, so the interpreter is just taking what I give it one at a time and telling me if there is output, it's telling me what the output it is and what the result would be of the statement that I'm giving it. Okay. So one thing to notice here when we used the interpreter in this interactive mode, that the previously fed statements and the results are kept in active memory. Okay, so I said A equals 2 + 3, and later on, every time I referred to A, it's had that value. Okay, so it's kept in memory. It remembers what I did. And then as new lines are fed into the interpreter, this fed program, essentially, I'm writing a program. It doesn't do anything interesting, but it is indeed a program. And it's being evaluated in the context of the previous statement. So when I said A plus B, it remembered the previous things that I did. It knew that A previously had been set to 5, and that B had previously been set to 3. And so it used those values when it did A plus B. Okay. So this is very convenient for when you're just wanting to play around with and learn how the Python statements work and what they do. We will use this interactive mode a lot in the labs that we do, where we're just trying to figure out what certain Python statement, how to use Python statements and just getting familiar with them. Not really for writing a program that we want to save or show anybody, but just to learn about how the statements work. So that's what interactive mode is good for. Now notice when the shell is closed, the program disappears. You can't save anything. So for example, if I type quit, okay, I have quit interacting with the Python interpreter. Okay, so I'm done. So if I want to interact with the Python interpreter again, okay, oh, I've started up interpreter again. So now if I say A plus B, notice my values of A and B are gone. It's giving me an error. It's like A isn't defined. I don't know what that is. I haven't told it what A is yet. So everything that I did up here, as soon as I quit the interpreter, it's lost and I can't save it. Okay, so I have to start all over again from the beginning every time I start up a new session with the Python interpreter. All right, and so obviously there's times when we don't care about saving stuff and we're just kind of playing around and trying to figure out things work, but at some point we actually want to write a program and we want to save it and be able to work on it and run it over and over again. So anytime that we want to save something, we need to interact with in script mode with the interpreter. So in script mode, you would have to create a file and give it a name with a .py extension. That .py says this is a Python program. And that file has to contain all the statements of the program that you want to be able to run. Okay, and then the interpreter is going to read all of your statements in from that file and execute them. Okay, so anything that you want to save, you have to interact with it that way. So let me give you an example. I have written a program here. It's called guessinggame.py. That is a Python program. I'll even show it to you. Okay. So if you look at this, it almost reads, I mean, you don't know Python yet, but it kind of just reads sort of like English, and it's not too hard to kind of get some idea of what it might be doing. So it says, from random, import randrain, print, welcome to Dr. Gonod's number guessing game. My number equals rand range 1, 100. Print, I'm thinking of a number between 1 and 100 inclusive. Can you guess it? Count equals 0. Guess equals int. Input. Please enter an integer from 1 to 100. Count plus equals 1, whatever that means. While not guess equal my number, if guess is less than my number, print too low. Try again. Else print too high. Try again. Guess equals int. Input. Please enter an integer from 1 to 100. Count plus equals 1. Print, you guessed it. It only took you, parentheses, guesses, dot, format, count, whatever that means. Okay, so you don't understand exactly everything in there because you don't know Python yet, but there are some things that you can, like these print things, you can probably guess what they do. While not guess equal my number, I mean, that kind of, if guess is less than my number, those are kind of familiar things. You could probably maybe make an educated hypothesis about what you think those things might do. So I can take this program and feed it to the Python interpreter by saying Python, and then, oops, I have to spell it right. And then instead of hitting enter and going into interactive mode, I'll give it the name of a program. Okay, so I'm going to say Python, and then I'm going to give it guessing game. .py. Okay, and so when I tell the Python interpreter to use this, okay, it will just run it for me. So notice the first thing it does, it says, welcome to Dr. Gonod's number guessing game. I'm thinking of a number between 1 and 100 inclusive. Can you guess it? Please enter an integer from 1 to 100. So I'm going to say 50. Too high. Try again. All right, 50 was too high. Let me try 25. Too high. Again. Try again. Let me try 12. Too high. Let me try 6. Too high. Let me try 3. Too low. All right, so it's somewhere between 3 and 6. Let's guess. Well, there's only 2 choices, 4 or 5. Let's go with 4. Yay, we guessed it. Okay, we guessed it, and it only took us 6 guesses. Okay, so that's what this little program that I wrote does. Notice it wasn't very long. And the Python interpreter, it was the Python interpreter's job to read in that program and know that this was what it was supposed to do. Okay, and interact with me and give me output and read input from me until I guessed the number that it was thinking of. Okay, and so if I wanted to run it again, I could run it again because it's saved. Okay, and I could go through the whole process again. This time 50 is too low, so I'd have to guess 75. It's still too low, and let me see, I'll guess 87. It's still too low. Let's see, I'll guess 93. Now it's too high, somewhere between 93 and 87. Let's go with 90. Too low, so let's go with 91. Yay! So again, it took us 6 guesses, but this time the number was 91, and it'll give me a different number every time I run it. So it can run that program over and over again. I get a new experience every time because it's using a random number for me to guess. And that way I can save it, I can run it multiple times, and it's not lost. So that's the advantage of using the Python script mode. And it will be, simple programs like this, and we'll even get more complex than this. But those are the kinds of programs that we'll be writing this semester as we are learning Python. Okay. So, as I said, you're going to be programming, writing programs. So a natural thing to ask is, well, what exactly is a program? Well, a program is just a sequence of instructions that specifies how to perform a task. Okay, so those sequence of instructions will look different in different programming languages because the instructions that are legal in different languages look different. Okay, so it depends on the language. So a program that you write in Python will look different from something that you write in C or Java or BASIC or whatever. Okay, because their languages themselves are different. But what you'll notice if you look at, especially after you program in Python for a while and then you go look at a Java program or a C++ program, you'll be able to understand it. I mean, it looks fairly similar because all high-level languages and even low-level languages have to have certain categories of instructions, these 5 categories of instructions. They're present in machine language, they're present in assembly language, and in high-level languages like Python. Okay, every language has to give you the ability to get input from somewhere. So that could be, like, very commonly you get input from a keyboard or from a mouse click. Okay, but it could be input from a file or, just some other device, a camera. Also has to be able to give output. Output is often displayed on a screen, but output could also be written to a file or some other device. Some kind of a light that blinks, or a speaker. They can all perform math, so they can add and subtract. And then eventually higher level languages can multiply and divide and take sines and cosines and all sorts of things. They all have to be able to do conditional execution. So they have to be able to check if a certain condition is true and then respond appropriately to that condition. So making some kind of decision about what action to take based on whether this condition occurs or does not occur. So this conditional execution. If this is true, do this. If it's not true, do this other thing. Okay, and the final category of instructions is repetition. So you have to be able to repeat the same thing over and over and over and over again. This is very convenient because oftentimes, things occur over and over again, and you don't want to have to write them hundreds and hundreds of times. You want to just be able to say, oh, this thing is going to get repeated. Okay, and so all languages have the ability to do this. And so once you know one language, and you can start thinking about things in terms of input, output, math, conditional execution, repetition, then you've taught yourself how to think like a programmer, how to use these ideas to express a task. And then once you have that way of thinking, then it's pretty easy to learn a new programming language. So once you learn Python and you're able to think in terms of the constructs that Python has, it'll be really easy for you to learn how to program in C++ or in Java, because they have the same kinds of, at least generally, the same high-level kinds of concepts in the other languages. So as a programmer, your job is to learn how to take a large task, like guess a random number that I'm thinking of, and break it into smaller tasks, smaller and smaller subtasks, until the language is able to perform those subtasks. Like, if I want you to guess my random number, I might say, well, the first thing that I need to do is a little bit of math to come up with a random number so that I have a number for you to guess. And then after that, I'm going to ask you, I have to give you some output and say, hey, guess my number. And then after that, I have to get your input. And so I have to say, be able to read what you guessed. And then after that, I need to be able to look at your guess and do a conditional execution on it. Say, well, if your guess matches the number I was thinking of, then I'll just tell you you're right. But if it doesn't, then I have to tell you to do it again. And that's where repetition comes in. So as long as you keep guessing wrong numbers, I keep repeating the same thing, and I ask you, and I tell you, no, it's wrong. Guess again. 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 And I just repeat that over and over and over again until you've guessed it correctly. So I'm able to take this complex task and break it down into input and output statements, math statements, conditional execution, and repetition. Okay, so next time we will look at the types of errors that can occur when you write a program.